All right, guys, we're going to jump into section 7.4 and 7.5. We're going to have a few different parts of this video. Really, this entire section, or these two sections, all about solving trig equations, okay? So we're going to need to use some of the thoughts that your Algebra 1, your Algebra 2 teachers taught you guys about solving equations. We're going to use basic algebra. We'll use a little more high-level algebra. We'll use trigonometry, all to solve for a variable. Whereas we were normally solving for x's or y's or variables, letters in Algebra 1 and Algebra 2. Here we're going to be solving for, theta, an angle, okay? And a lot of this will harken back to inverse trigonometry, where we're giving you values and you were looking for angles. So we're going to give a little reminder here, but we're not really going to talk about restricted domains, because if you look down at number 1, you'll notice that we actually give you a domain for our variable. Most of the time, it's just going to be 0 to 2 pi, one rotation around the unit circle. So instead, I'd rather remind us of kind of our quadrants for our inverse functions and where we might be looking in one rotation around the unit circle. Okay, so remember, the unit circle has 4 quadrants. In the first quadrant, we're positive, positive in the xy, negative, positive in the xy, negative, negative in the xy, positive, negative in the xy. And we remember that it's cosine, comma, sine. Okay? So I just want to talk our basic 3 trig functions. For our sine graph, if we're looking for a positive sine value, that will happen in quadrant 1 and 2. A negative sine value in quadrants 3 and 4. For cosine, if we're looking for a positive cosine value, that would happen in quadrants 1 and 4. A negative cosine value in quadrants 2 and 3. And for tangent, our positive tangent values, we'd be looking in quadrants 1 and 3. Remember, because it's sine over cosine. So quadrant 3, we divide 2 negatives and get a positive. Negative tangent values, we'd be looking in quadrants 2 and 4. That should say 2. Okay. As you can see, a lot of the time, unless we're working with our quadrantals, our 0, 1, our 1, 0, our -1, 0, or our 0, -1, a lot of times we're going to be thinking for pairs of answers, 2 answers. That's almost going to be our standard here for solving trig equations with this type of domain. All right. Now, we are talking about inverse functions, and there is algebra ways that we can solve these, okay? We've already kind of talked about what this might mean, okay? But we're asked to solve, so we're going to come up with theta equals. So similar to inverse sine of root 2 over 2, we're looking for the angle measures between 0 and 2 pi that have a sine value of root 2 over 2, okay? If you're looking for algebraic ways to solve this, we can't divide by the letters sin. Normally in algebra, you see something attached to our variable, you're thinking divide. Well, we can't do that. What we can do, and you're probably going to not want to do this a whole lot, is take the inverse sine of both sides. As you guys know about inverse functions, they undo functions. So inverse sine of theta basically cancels out to just be theta. So if you want to do this every time, Mr. Newberger, some of our teachers, some of our students, probably won't want to take the step of writing this all out because they understand that this equation up here means, all right, find the angles for which sine values are root 2 over 2. Okay, but if you want to do this, that's okay. We just need to make sure we're thinking of 0 to 2 pi. Let's refer back up top. This is a positive sine value. It happens in quadrants 1 and 2. Sine is root 2 over 2 at 45-degree reference angles. Okay, but we're thinking in radians here, so we need the angles of theta equals pi over 4. And in the second quadrant, that 45-degree reference angle would get us 3 pi over 4. Okay? I'm going to show you that we don't necessarily need to use this inverse notation here. This is asking us what angles between 0 and 2 pi have a cosine value of negative root 3 over 2. Okay? All right. Cosine is negative in quadrants 2 and 3. Cosine is root 3 over 2 at 30-degree reference angles. Again, we're looking in radians. Quadrant 2 would be 5 pi over 6. Quadrant 3, 7 pi over 6. So we still need that good inverse trigonometry knowledge. We still need that good unit circle knowledge, thinking of our reference angles and for what angles cosine would be some version of root 3 over 2, in this case negative. Okay? All right, what if we asked you to solve for all real solutions or all possible solutions? As we know, the unit circle or trig graphs, the domain is negative infinity to positive infinity. It will go on forever. Okay? So if we asked you for all the possible solutions, there would be an infinite amount of them. Here, we restricted the domain from 0 to 2 pi, which will be one of the options, or 0 to 360 degrees. But if we ask you for all the real solutions, this is going to go back to something that we talked about when we were graphing trig functions in terms of our asymptotes on those the reciprocal functions. Okay. Let's say one of our answers, let's say we were just very simply doing, let's actually do an example down here. Same question, sine theta equals root 2 over 2. We noticed that theta equaled pi over 4 and theta equaled 3 pi over 4. Those were our two solutions from 0 to 2 pi. Okay. The infinite amount of the rest of the solutions. So another rotation around the unit circle. That would be between 2 pi and 4 pi. We can keep going with rotation after rotations. We want to think about our coterminal angles. And remember, to find coterminal angles, we were adding or subtracting 2 pi or 360 degrees, because that's just an extra revolution around the unit circle. Okay? So if we wanted to use this notation to think of all of the solutions, we would say plus 2 pi k, where k is an integer. Which means no matter what you plug in for k, any integer, 0, 1, 2, 3, negative 4, negative 5, negative 1, negative 2, you will end up at an angle whose sine value is positive root 2 over 2. Okay? So make sure you are very careful of what the domain is, whether we're asking for all of the real or all of the possible solutions, or we're restricting the domain from 0 to 2 pi or 0 to 360. Okay? All right, I just wanted to show you one example of that. You can do the second one on your own if you would like. Take the square root of both sides. Why don't we do this one together just so you guys don't get into a bad habit here. Cosine squared to get cosine theta. Take the square root of both sides. The square root of 1/2 would end up being root 2 over 2. Happens to be a value we have on the unit circle. You can't forget, when you take a square root in an equation, you need a plus or minus there. Okay? All right, so if we want to think of the angles where cosine is either positive or negative root 2, we're actually going to have 4 of them. They're going to happen at 45-degree reference angles. Okay? We're going to be at pi over 4, at 3 pi over 4, at 5 pi over 4, and at 7 pi over 4. But they have asked us for all real solutions to theta. All of these plus 2 pi k, where k is an integer. Pi over 4 and 7 pi over 4, that would be the positive root 2 over 2. 3 pi and 5 pi over 4, that would hit the negative root 2 over 2. All right. All real solutions. Add that 2 pi k when k is an integer. All right, let's turn the page. I promised you some higher level algebra that we'll need. Here it comes. Okay? Just like 2x squared plus 3x equals 2 is called a quadratic equation. where you would want to set equal to 0 and factor, this is also a quadratic equation. Okay, check out the similarities. Instead of an x, there's a sign. That's it. So let's subtract 2 from both sides first, because we know to solve a quadratic equation, when we have a squared variable and a to the first power variable, we need to set it equal to 0. Your options here now are factoring or using the quadratic formula, just like they were in Algebra 1. I'd suggest factoring. 2x squared plus 3x minus 2 would factor the same way as this. Instead of x, though, we'd have sine theta. So we get 2 sine theta and sine theta. We get a 2 and a 1. We get a minus and a plus. Okay. The zero product property that your teacher taught you back in Algebra 1 says that if two things are multiplied and set equal to 0, that means either the first quantity equals 0 or the second quantity equals 0. Let's get the sine theta by itself. We add 1, we divide by 2. We get sine theta equals 1/2. We'll solve that in a minute. Subtract 2, we'll get sine theta equals -2. Now, if you remember from back in graphing, the range of our sine graph is -1 to 1, which means there are no angles for which sine values are either greater than 1 or less than -1. So we're going to throw out that equation. Doesn't exist. Okay? This would give us no solution. But we still have this one to work with. We're looking from 0 to 360 degrees. Keyword here, we're working in degrees because of the domain they gave us. Sine is positive in quadrants 1 and 2. Sine is 1/2 at 30-degree reference angles. And we're working in degrees, so theta will equal 30 degrees or 150 degrees. One more algebra piece that a lot of our students forget in a problem that looks something like this is the first step of factoring is always to factor out a GCF if there is one. Now, there wasn't a GCF here. These three terms were not all divisible by the same thing. We couldn't pull anything out. Okay? Here, however, we have two terms that both contain a cosine theta. Let's factor that out of each of our terms. What will remain, if I divide both by cosine, is tangent theta. Don't forget the +1. A lot of students will forget that +1. Okay? Again, we have two quantities that multiplied together equal 0. Let's set them both equal to 0. Cosine is 0 at 0 degrees, at 90 degrees and 270 degrees. That's great. Let's subtract 1 from both sides. Tangent theta. When would tangent be -1? Well, let's think. Okay, going back to our inverse thought. Well, first of all, tangent is negative in quadrants 2 and 4. Tangent is going to be -1 when sine equals cosine. Okay, or I guess the opposite, since we're thinking negative. Okay. When does that happen? That happens at 45-degree reference angles, where both sine and cosine are √2/2. Divide something by itself, you'll get some version of 1. We know tangent's negative in the second and fourth quadrants. Our 45-degree reference angle in these two quadrants would be 135 degrees and 315 degrees. And our final answers then, in ascending order, which is nice but not necessary, would be those four angles. Now, if I change the directions to this problem to say solve for all possible or all real solutions in degrees, nothing would change here about our work, but what we would have to tack on to at the end would be plus 360k, where k is an integer. Okay, we kind of always start with that 0 to 2 pi or 0 to 360 thought, even if we're solving for all the real solutions. We get our two answers, maybe we get two pairs of two answers because we ended up with really two equations, we end up with 4. Okay, stick with those, but then tack on that extra notation there. All right, part 1, all finished up.